Hey there, YouTube. Just want to go through what it is that you need to be successful when managing records on Amazon Route 53. First of all, just to provide a high-level overview for what Route 53, it is a way to manage domain name service records, which are used for pointing a domain like www.qled.io over to an IP address is the ultimate place that is going to end up at. So in Route 53, one of the important things you're going to need to do on a regular basis is add an A record. So what I'll do right here is switch over to the screen right here, and let's go into what this actually looks like. So when you're in the AWS console, what you're going to want to do is navigate and type in Route 53 and then end up in an area that looks like this. You'd want to select hosted zones and then pick a zone that you want to work with. Now this particular domain that I'm working with here, it doesn't point to anything, it's not actually live, nor is it going to be used for anything that really matters. So in this case, I'm going to go ahead and click Create a Record. And the first type of record I'm going to do is I would supply no name in here. I just want a basic A record, and I'm going to point it to an arbitrary IP address in here. Now this needs to be a valid IPv4 address, or you can have multiple addresses in here. They would then resolve to, typically in Amazon terms, you'd allocate an elastic IP, or if you're working with a third-party provider, they may supply an IP address for you to point things to. So if you were to go ahead and select Create, you can do that, and then you would see your basic A record up here and here. The other important thing that really matters when it comes to DNS is the TTL, or the time to live. Now, what that does is that's a measure of seconds before the record needs to be re-requested by any downstream computers or routers along the way. So as an example, if you were to query qled.io one time, and then your computer would then store that cache locally in its resolver, and then you work up the next place on the path out to the actual authoritative name servers, you would then see your router may cache that also for a similar time for 300 seconds here. And then working your way up, the ISP may cache that as well. Amazon's Edge servers for DNS may actually cache that as well. And ultimately, the authoritative name server will be handing that out. And it's a request to cache things for a particular duration. Now, clients aren't obligated to do that. However, they should. And generally speaking, most things like browsers, DNS resolvers, routers, and so on do respect that time to live. An important thing to note is when you are about to migrate a service, you're going to want to drop the TTL well in advance of the caching, the maximum caching time that you have that set for. So if, say, you're migrating a service over, drop that TTL in advance, maybe something even as low as, say, 60 seconds, somewhere in there. That gives you opportunity to flip back to the previous one if you need to with minimal downtime. Assuming all goes well, though, you drop your TTL down, you point things to the new server, and then traffic starts sending there. If everything looks good, you just bump up the TTL to the normal time, maybe an hour, maybe a day, whatever is appropriate for that particular service, and you're good to go. Next, in Amazon's Route 53 side of things that's interesting is the alias. An alias allows you to point to a service managed by AWS where they handle the integration and the actual IPs that need to be pointed to without you needing to intervene in that. So as an example, a load balancer on Amazon can then point, they scale those in and out, and so because new IPs are added that would be public facing, they need to be registered, and then as the traffic scales down, or those load balancers scale down when traffic decreases, extra IP addresses would be allocated but need to be removed. So by having an alias in there that in a record level, those are dynamically managed and served out in a way where you don't have to fiddle with that. Same thing applies for an S3 website. It's super handy because you can then now use this top level domain to point there. An interesting constraint with DNS is this apex level, or the most top level domain that you have access to. In this case, here's QLED, which is really a subdomain of IO for Indian Ocean, but IO is often kind of used as a little trendy thing for input and output for more techie type things. So anyways, so this top level domain right here, this top level one, it must be an A record. So in order to work around that, Amazon provides this alias mechanism. Super helpful. The next type of address we could do is a CNAME record. So a neat CNAME record here, you could work with a third-party hosting company. Maybe they run a software as a service web hosting thing like Squarespace as an example. You would then want to point over to their service, and they would more than likely provide you a CNAME record. So we could call this, hosting.somethirdparty.com, and you might want to set that for a 1-hour TTL. And then this, anytime you visit www.qled.io, DNS on the client side of things would look up, and it would respond with this address here. So we create that record there. Anytime someone visited this site here, they would get pointed to this hosting.somethirdparty.com. And then ultimately, this hosting.somethirdparty.com would eventually resolve to an A record or a quad A record. Now, quad A record is the same thing as an IPv4 side of things, except it is in the IPv6 address space. Next record that we're going to talk about here are the mail exchangers. So mail exchangers are really interesting. This is how inbound mail coming to your company or your domain really would be routed. So in this case here, you have a priority number right here and then an address that you are pointing to. So an example, if you're configuring G Suite, which is a very common scenario, you would have these different priorities right here. So you'd say, okay, priority 1 is this particular mail server here. Interesting thing in here is they end that with a dot after the domain. That's just the convention, so keep that in mind when you are setting that up. And you can have multiple records with the same priority as well. And so when you're configuring your mail servers or the way mail is received and routed to you, you want to make sure you get those priorities set up correctly. And then there is no name right here typically associated with the top level domain when you are setting mail. Now you could certainly create subdomains on Route 53 and have different mail servers configured there. That would be an appropriate use case for having multiple MX records in there. And once again, you could alias MX records. I've never actually done it, so I'm not sure what the use case is there, but that's really interesting that they expose that. Let's talk about text records. These are more often used for validation that you own a domain. So let's say you want to set up, I don't know, Google Analytics, Google AdWords, maybe register an SSL certificate through the Amazon Certificate Manager. They insert a TXT record on your domain, they query it, and by adding these records, they validated, yes, you actually have access to editing records of this domain and therefore are trusted in there. So those are text records. Pointer and service locators, these are not really typically used for the day in and day out, so I'm going to skip that as that's totally outside of the scope of this. And then sender policy framework, what's interesting here is really they're just giving you some convenience here. It's really a text record, but I guess they're giving you that right there. You can set that in there. That is the essentials for doing the typical day-to-day record management of a domain in Route 53. Let's talk about migrating domains. So if you have a domain and it's hosted on, say, GoDaddy, but you want to now move that over to Amazon Web Services, what's the sequence of events that you should follow? That's a really important question because the sequence of events determines how successful you're going to be or how much access you have to be able to change records while a domain is moving from one registrar over to another. So the first thing you're going to want to do is create a hosted zone on Route 53. Once you've done that, you will have these name servers available. The next step in there is to create a copy of all of the existing records on where you are currently managing DNS. So that could be on GoDaddy. You may have your own bind server or something like that. But at the end of the day, you need to get all of the records imported, and you're going to want to double check that they are correct. So if we are checking those records, you might want to first go, okay, dig www.qled.io, and you would get a response of some kind. Now I just got this set up on here, so I'm not getting any answer from it. So the question is, all right, you would presumably get an answer by using dig from your existing name servers, and it would say, okay, this points to 1.2.3.4. And you'd want to do the same on the Amazon side of things just to double check that things are correct. In this case here, so we'll go dig at, which allows us to specify the name server that we want to query. So I'm just going to paste that in right there. Oh, I'll typo there. Yes. Oh, we'll just open a new terminal there. Looks like that one got stuck. So So we could do dig at ns1200.awsdns-22.org. We could do www.qled.io. And then we would then get our CNAME record right down here, pointing to hosting.somethirdparty.com. Once you've gone through the entire list of every single record in there, whether that's a TXT record, a MX record, the A records, and you'd want to read through the man page on dig because there are different commands for different types of records in there. So they have this -t argument right here where you can say, okay, use that particular TXT record, or otherwise you could be like -t TXT or -t NS for the name servers, and that's how you could check that out and double check that all the records are correct when you point it. Okay, so let's say you've got all these records, you've got this totally resolved, everything is 100% matching up, the TTLs are the same, the target server names are the same. Then you update the name servers on your current registrar to the new target name servers on Amazon Web Services Route 53. Once you've done with that and you've allowed things to sink in a little bit, then you are ready to now transfer the domain from one registrar to the other. And the order of that is important because during the time from when you initiate your transfer to when the transfer completes, you may not be able to edit the existing records on your old registrar. That, and once the transfer completes, the old registrar may in fact terminate serving your DNS records out from their end because, like, hey, you moved out, you're no longer here, bye. We're not serving you because we're not doing that for free. So that's something important to know. So if you want to minimize any kind of outages that would occur, you want to make sure you get that transfer done in a way where you are not stuck with all of a sudden having to figure out records at the last minute, or also in a way where you couldn't modify records while the domain is being transferred. So that is an absolutely critical tip to running your DNS on Route 53 and handling the more complex scenario of how you transfer a domain from a third-party registrar into Amazon Web Services. I hope you find that useful. Thanks again. Bye-bye.